Hi guys, I hope you're good since last video. So comment your ideas, like and subscribe, and join the Grass project. The link is in the bio. So this time, for you to not be frustrated to the end, I just want to show you what's the end result first. So here I'm asking for a weather forecast for a city in Japan, and I'm getting the weather forecast back to me. So what is interesting with this agent and local LLM process is that you will be able to build your own plugins, your own custom logic, your own applications or services, and get the LLM use those services and get the result for you. So you'll be able to have several local LLMs, custom plugins, and call services. So this is a kind of orchestrator, and it's going to be using a code interpreter in order to use those services. So that's what we're going to see, how to build this. So let's start with all the installations. So first we create a virtual environment. So we're going to activate it. I'm just going to install Python 3 Venv just to create this environment. I'm not going to fast forward here because it's going to be pretty quick, but some parts of the videos are going to be fast forwarded. And I didn't do this video in just one day. So if you see dates that are not the same day, that's normal. So we're going to call this virtual environment Task Weaver. So that's the name of the software that we're going to install. It's from Microsoft. So source Task Weaver being activated, and we get this virtual environment activated so that whenever we install a package, we get it in the same environment, and it's easier to retrieve and control. So let's go in the GitHub repository of TaskWeaver, and we're going to clone the TaskWeaver's repo. Let's get the link. Do a git clone. We don't even have Git installed, so let's install it quickly. Yes. Okay. Now, just check Git. Yeah, Git is working with or without the virtual environment. Because I had it installed without the virtual environment, but not in the virtual environment. So that's why. So here git clone, and we clone the repository. This step is pretty fast also, and we're going to install the packages. So we cd to the folder Task Weaver with a capital letter, pip install -r requirements. We're going to install all those packages. So while it's installing, I'm just going to open another terminal. But just to show you what is in the requirement, the basic ones. Some Python libraries, request, Panda, NumPy, Seaborn, OpenAI. Just going to activate this and show you the architecture of it. So the user makes a query. The query goes to a planner. The planner sends it to a code generator. So there's examples. Here the developer will have his plugins and examples. So the code generator will be able to interact thanks to those plugins and examples with the external service or API. So the developer is going to be developing this. We're going to be doing the development of those plugins in this tutorial. So this is just to have an overview of how internally it works. This is available on their GitHub repository. So we're going to install Ollama. We're going to use Ollama to have our local LLM. So that's the command to install it. It's going to be downloading Ollama. We're going to install Chainlink, so it's optional. This is for the web UI. So you can use TaskWeaver in the terminal initially, and they added also the web UI through Chainlight. We install Longchain. Longchain and Tabulate for SQL database interactions. I'm just installing what is I find interesting, because there are some plugins which are already in the project, and when you install all of those, you'll be able to use those plugins also. So I'm just gonna keep those installations and versions into my own requirement file. So you can use Bitphrase, full requirements. It's just to keep it. So next time I'm just going to launch this one. I'm going to call it TaskWeaver, so I know what it is talking about. And here the requirements are a bit longer than the initial ones. Okay. So Ollama is installed. Use a local bin. Ollama, so we got it working. We can install Selenium and Pillow. Same, this is optional install. This is for web search. There's a plugin to make some web search. We're not going to use those plugins. We're going to make our own. But I just wanted you to know about those. Navigate to default plugins. So we're going to navigate to the folder. So we're in the root folder of TaskWeaver. We go to project. Inside projects, we go to plugins with 1G. Plugins, and here are all the plugins which are they're available. There's a PY file and the YAML file. So for anomaly detection, for example, you have two different files. For SQL pool data is the same. So always the Python file and the YAML file that will be explaining what is the application about. So here is just an example to see the SQL pool data. Why? So it's all wrapped into a class. So now we're going to just go and find a free API endpoint. We're going to use openmeteo.com. We're going to get weather forecasts. Just let's go through it quickly. We're going to use the free version of it. Doesn't require any keys. We're going to go in the GMA API. So it's Japan API and maybe Korea also. Go. We have some parameters, hourly, or the JSON returned object, how it looks like. And we're just going to try to find where is there should be code snippets. You see here, API response. There's different code snippets. we use the Python one. And here we get the installs that we need to do. And here the example code snippet that we're going to use as an example in our project, just to test that it works first. And after we're going to be building our own logic around it. Yes, so this is Japan and Korea. That's good. So install the weather API, pip install OpenMeteor / dash requests. So this is almost the same as requests. There's not much. But we need to install these two packages, 3. And here we got already Numpy and Panda, but retry requests and requests cache, we don't have it. We can install it. And we're gonna open a file. We are in the plugins folder, so that's where you need to create your files. But this file here is just to test, so it's just a Python file that can be created anywhere. So OpenMeteor.py, we just pass the code. Okay, so we get some responses that can be cached. There's a retry also. So the retry is taking in account the cache session, and OpenMeteor is taking in his session the retry session. Okay. So here we have the URL endpoints, GMA, just for Japan. Let's put a little comment here. Oh, just here. So GMA for Japan, and also Korea, I think. But we're going to use it only for Japanese cities. The parameters. So here we have latitude, longitude. We're going to keep those numbers just to test the example. Here in the hourly, so longitude. Okay. In the hourly here we have temperature 2M. So 2M means 2 months. We're going to get 2 months of data coming back to us. It's a bit huge. Maybe several lines. Temperature, wind speed. I don't know if it is linked. But yes, you got those parameters. The response is going to call the API with the URL and the parameters. We get the response, and we're going to get the first location, 0. It says here that you can add a loop if you want multiple locations. And here will be printed the latitude. So just a reminder of the latitude and the longitude, the elevation. And we get from the response the time zone. Okay. After that, going to process the data hourly data. The order of variable needs to be the same as requested. So hourly. This is the variable that is going to be used in this hourly temperature 2M. And here we create this Panda data frame. With the start, so response hourly time. On the end, we're going to use the end, and we get the interval here. So this is in seconds, and the frequency at the end, time delta, hourly interval. Okay, so all comes from this hourly variable. And after here, the hourly temperature 2M is going to be used here to create a field for it in the data frame. That's good. What we might need is just to have representations of those different variables, so we know more about the API, how it renders those variables. We've seen there's a JSON returned, but here we see that the code is building on that data frame, which is customized actually. So hourly temperature 2M. I'm just going to print those. I want to see how it looks like. And here we put our variable hourly temperature 2M. We might need to put some space between the outputs as we're printing a lot. So just let's put a space here. And another space here. This is just a bit of formatting. We're going to test it. And after, in the second part of the video, we're going to be building it, our own plugin that is going to use this API. So first, you find your API, you find your code, test it. So we're following all the process here. After having tested it, you start building your plugin. So for sure, if the plugin doesn't work, it's not because of the API. It will be your syntax or the way you did that. Yeah. So here we're going to be printing the hourly data frame at the end. Okay. So at this time you will be able to use your coding skills to create different little apps, plugins, and incorporate those to this TaskWeaver project, and incorporate your local LLM as open source LLM becoming better and better. We will get the chance to have more abilities to work locally. So here I'm just going to call the API, and we get the answer. That's good. We got our hourly temperatures. So Pyro will become. We create dependencies for Panda in next major releases. So I might install this also. But you see here, we get all the different data returned to us. So let me just activate here in a third terminal the environment. So we got it. We're still in the same folder. We have our OpenMeteo PY, and we will be transforming this into a plugin, as now we know that it works. I'm just gonna open the other files to have examples. So this is PY. So the PY of the SQL pool data. So how is it built? You see there's this class wrapper around the API code. So function, and there's some imports that are done on the top. Okay, so that's how it is made. So it's not complicated. We can check the YAML file. So I've checked the YAML file before I put some different comments. So the last part, the configuration, we won't need it because we don't need any API keys. call this API, but in case you have a service needing authentication, so you'll need the configuration at the end. And after we have the three different parts here, which are the description, the second part parameters of your function, and the third part what you want, like the returned variables. We're gonna open the YAML file and start building. I'm just gonna fast forward this step. So creating our custom weather forecast plugin, .py on the YAML file, and I'll be explaining you this after this little break. So it's time to comment your ideas, like and subscribe, breathe a bit. Now you have everything set up and you're ready to make it work. And here we have the request has been imported, the cache. So I kept those two. We need Panda, we need the retry. And here from TaskWeaver plugins, we need plugins and register plugins. So that's the class wrapper. So the plugin here from TaskWeaver plugin, put it in the class definition as an argument, and we have the wrapper register plugin. For the name of the class, it's an arbitrary name. I just called it OpenMeteo Japan, so you call it the way you want. And here are the arguments that we will need. We will need just the latitude and the longitude. So we define those on the self-longitude, self-latitude. We kept the caching process, the retry of OpenMeteo. We didn't change anything. The URL endpoint is the same. As you see, I kept the comments. For the parameters, we got rid of the numbers, because now the numbers, the LLM will provide those numbers. From the parameters, we kept the temperature 2M, so we're going to get 2 months of data coming. It's a bit too much, so I'm going to be truncating it later on. The response is the same, calling the API, using the URL and the parameters. We get the first location response as before. Alright. So you see the code didn't change a lot. You just do some adjustment. I got rid of the printing parts of our own printing. I could have got rid of some of the other ones because they won't be shown. And here the hourly data, the data frame is the same. Okay. So everything is the same here. Temperature 2M, from hourly data. From hourly temperature 2M that we created the NumPy. Okay, so here hourly data frame. That's here that I'm going to be limiting the response output. So we just get the 20 first rows. So I just put head 20 at the end for that. And what we've added to this code also is the try and accept. Okay, so here we have the try. So we want to catch the error, so the LLM can return the error to us if there's any. So if the hourly data frame is, the length is equal to 0, that means that we didn't return anything. So at this time we just tell to the LLM, we return this. Are you sure the city that you've chosen was situated in Japan? The result is empty. And after just put a sorry mate and geography. And else, so if it works, the message is almost the same. So we're going to be extracting the latitude and longitude. say how many rows there are, and we ask it to format it into a markdown. So it might be easier for the LLM to read like that. So here we limit it to 20 rows. So that was for the OpenMeteo.py. Now the OpenMeteo YAML. So the first pass is to say, just to describe what it is. So the name is OpenMeteo. It has to be the same name as the file. Pull the data from the API call. I'm just gonna say that it's a weather, just to for the LLM to know what it is. The API return response. This plugin takes user request when requesting weather forecasts from a locality in Japan. It must extract the city and locality in Japan, so the latitude and longitude coordinates in order to be able to get the weather forecast based on the World Geodetic System 1984, which is the standard for measuring positions on Earth. Alright, so from the returned data, provide to the user an easy human readable format, or explain it using easy words. So here 84, see the standard measuring data. Just want to show you the end of the sentence. We'll explain it using easy words, like if you were explaining the return data to a 7-year-old kid. Work autonomously until you return the response to the user. Do not disturb the user with questions, as this plugin will get a data frame with date and temperature. And here I provide an example. And in the example, I just show how to use the function, how to put the variables into the function. Only data frame, OpenMeteo, get the weather forecast from the return response and summarize it in an easy, readable way. So result equal OpenMeteo, and I put the latitude and longitude. So whenever you write OpenMeteo, it has to be the same as the function on the name file. And the name at the top here, same as the name of the file. Second part, your parameter defined in the py file as function parameters. So we have two for us. We have a longitude, it's a string, it's required, and the description. We just say this is the extracted longitude from the user request that you have extracted from the locality, city in Japan. So get the longitude of the city mentioned in the user query and find its longitude based on the World Geodetic System 1984 standard for measuring, etc. So that's what I did. I did the same here for the second argument. And after you have the third part, it's what you want it to return and forecast. So the name is hourly data frame. It's a Panda data frame, that's the type that we're gonna return. And the description, this is the data frame containing the data from the API response. The weather API, maybe I would write, that you will analyze and return to the user in an easy, understandable way, so that the user is well informed. The data frame has dates and temperatures for each day, for each date mentioned. Answer the user based on this date and temperatures. Always provide the user in the answer the name of the city, the latitude, longitude based on the World Geodetic System 1984, used to locate and remainder. But it's not going to do this, but I'm writing as much as I can, and it depends on the capacity of the LLM that you're using locally. So taskweaver underscore config.json. So I'm just showing you how to navigate to it. You go taskweaver project, and in the project folder, you get the taskweaver underscore config.json. So I put one as a backup. This is the original one, that's the one you're gonna have. This is the model, for example, when you're calling OpenAI. There's an API key that you need here to provide. While our own that we use here, it will be this one here. So I'm just gonna explain it quick. So this will be the endpoint that we're gonna call. The type of API is Ollama. As you've seen, we've installed Ollama for that. We don't need any API key, so no API key needed for it's free of use. And the model that we're going to use is Orca 2. It's a very light model that answers pretty quick. I tried with some other models, but it took too much time for my computer. So here the quality of the answers will depend on the model. So this model is not the best, but still we can do the tutorial with it. Chainlit, so for the web UI. You can also go to Taskweaver, Playground UI, Chainlit, run app.py, and you get the access to the web UI. So you can also interact with Taskweaver using the web UI. This is just to show you that it's possible, but we're going to use the terminal. We are Linux people, so I'm just going to put it dark, for example, and here it's dark. That's good. I'm going to close it. And here you can just put files in. So you launch Taskweaver, Python 3 -m Taskweaver -p, and you indicate the folder where the project is. I'm gonna start prompting Taskweaver. I have already Ollama running, but I'm gonna explain you more about Ollama while this prompt is being processed. I'm going to NARA on the 3rd of February 2024. Provide me with a weather forecast for that day. Let's send this. Do not ask me I'm trying to tell him that, but he's gonna stop sometimes and ask me some questions. But the best would be that it works autonomously. So do not ask me for any confirmation. Work autonomously using available plugins maybe. Okay, so now it's running. It's gonna take a while. I'm gonna fast forward those parts, and at the end I'm gonna show you the logs so you know how long it takes to get an answer. So we just wait a few seconds and we're gonna pass to the next part of this video showing you maybe Ollama. Let's see. So here is the console of Ollama. You see 200 it has been posted, and I'm going to explain you quickly here how those interactions are done. So here I'm getting the logs, which is good. I ran Ollama here, but I'm going to go to another terminal just to show you something about this to know. So sudo systemctl status Ollama. So here I've turned off the service Ollama in systemctl, so I can use the command yamaserve and have the logs live and see what's going on. So that's what I wanted you to understand. So let's say here, for example, I do a sudo, I'm just going to clear this. I'm just going to do Ollama serve. Nice. I get the logs in the terminals and I can see what's going on at every single request made to the Olyama server. So I stop this and I'm just gonna start the service Olyama, because now by default when you install Olyama it's gonna start the service into your systemd. So doing that is gonna take the port. So YamaServe now, you see the port is already in use. So what you can do, you can just keep the control. You can stop Olyama after having installed it if you want to see the logs, so you can see what's going on. You see inactive now. As it is inactive, at this moment you'll be able to serve it, and while you're serving it, you'll be able to download any model that you want. So I did this, so the model name, I did this especially to be able to have a terminal and just to see the logs. So Olyama run Olyama 2. No, it's not Olyama 2. What's the name again? It's Yama. It's not Olyama, it's Yama. So this is just an example. If you wanna download the Yama 2, you get it downloaded. I'm gonna stop it. And I'm gonna clear this. Olyama list, that's the one that we have. Orca 2. That's the one we're using because it's a small one, just 3 gigabytes. I mean 4 gigabytes almost. And I'm just running it like that. Maybe I need to put the 2 at the end to recognize it. So on the other side, TaskRiver is still processing. I just want to show you here the logs. You see, we can see all the logs. That's what we want to be able to troubleshoot our plugins and know where is the issue. If it is in the Olyama side or if it is in the plugin side. So here, for example, I just ask a question. What is the most populated city here? Capital city in Asia. So it took approximately 12 seconds, 10 seconds to answer. And we need this kind of responsiveness in our computer in order to be able to work with TaskRiver. So interaction errors. So TaskRiver it's not perfect. So I got some errors happening. So you're gonna be able to see those errors. So those errors, they're not regarding the plugin, they're regarding the code interpreter of TaskRiver and how it processes, how it handles all the requests. So here is saying I'm opening the weather API call for Nara, Japan on the 3rd February 2024. Please wait a moment. I say okay. Keep going, please. So I didn't want him to stop and tell me that. I want him just to keep going and do the job. Just gonna wait a few seconds and see what's the error. Okay, so you can see how long it takes to get an answer from code interpreter. So extracting the temperature, precipitation values from the response. So here it's going to start outputting the plan. Format the temperature in Celsius. Precipitation in millimeters. Send the forecast to the user. So now it's running pretty smoothly because I didn't fast forward anything. Just want you to see how it goes. So we got the response coming. The temperature is 5 degrees Celsius and the precipitation is 10 millimeters. And after the answer I just got this big chunk of errors. Cannot update message when update is finished. So we can still go on internet and check this answer and see if it is correct. So this error is not stopping the process, so we can keep going and prompting. There were an error and I didn't get a full answer. Can you repeat please the answer? So here we can just check. It's 9 degrees. Just gonna close this. This is nada. Just check the initial answer that is has come up with. This is the whole day. So we got 2, 2, 2. Okay, so you see we got another error again. So what is the weather forecast? Can you just provide the answer? And not ask me to confirm or interact with me until you get the answer. So here I'm just fast forwarding the steps. I'm showing you the interaction. It's telling me that is going to open the weather API and try to get this weather forecast again. Okay, keep going please. Now I'm waiting for the answer. Just let's go here to the console so I can show you how long it takes. First answer said 7 minutes, 1 minute 30, 145, 149, 2 minutes and 3 seconds. So that's how long it took for each interactions. I had to wait 7 minutes for the first one and between the 2 and 3 minutes for each of the other interactions. Here in the plan, extract the temperature and precipitation values, and now it's providing me the answer. The temperature is 6 degrees Celsius and the precipitation 10 millimeters. So now we got the output that we wanted to have without any error. Before we got something similar, but we got just after that a big chunk of error, so this can happen So I prefer you to see how it is. I could have just cut it and show you that it's all fine, all perfect, but it's not. What about... I'm just gonna ask straight away after that, because you remember in the code there were some kind of let's say caching process or retry. So now maybe it knows how to use the plugin, and knowing how to use the plugin can answer a little bit quicker and know how to format the answer and everything. So what about Tokyo on the 8th of February? What is the weather forecast? So here I got the answer again. The temperature is 10 degrees Celsius and the precipitation 30 millimeters. So in general I got the temperature close to what I see in some other websites. But for the precipitation, I don't know if it is the conversion that is not good, so the LLM is not good enough to make the good calculations, or if it is the API, which is just giving us not really good numbers. So say yes, good. What about, just gonna choose another city. What about Sapporo? And here, instead of giving one date, I'm gonna give a range and see how it's gonna handle the range. So we might get an error, or we might get maybe an average from the 5th of February 2024 to the 10th of February. So what is the weather forecast? As you can see, sometimes there's some typos. We still get the answers every 2-3 minutes. Let's check here for Tokyo. Which date was it? On the 8th of February. Yeah, so this is right, it's around 9 degrees. We got 6 degrees, we got 9 degrees. So here it says 6 degrees, 10 degrees. So it says 10 degrees, which is very close to the 9 degrees that we have here. For the precipitation, we have 1 millimeter, 4 millimeters. Not much rain, while here it's telling us that we got 30 millimeters. We can check straight away Sapporo before getting the answer from the LLM, so that I don't need to fast forward this step. Okay. Sapporo is very cold. We are on the 0. Just go to February straight away. So from the 5th, let's see, -2 in the morning, from 0 to -3 in the afternoon. I mean, this is the afternoon, and in the morning it can go to -13 on average. So let's see what the LLM is answering. So it's still calling. -3, -2, -1. This is for the afternoon, and the morning we have the -12, 10. Okay, it has made the plan. The temperature is -8 degrees Celsius. And the precipitation is 15 millimeters. So I think it's snowing, it's not raining, but still. So you've seen how to make your own plugin. You can incorporate an API and use TaskWeaver to handle the process using his code interpreter, which is working as an agent. This agent is going to choose the right plugin. You can indicate it which plugin to use, and you can use Ollama on the side, or you can use some other LLMs, some other project like maybe LM Studio. So here what we can say is that we can improve this by using more performant LLMs. So here I'm using Orca 2. You can also have it hosted on a cloud instance, an instance having more RAM than your local computer. At this moment you'll be able to download those big models, which are very performant, and have something working for you locally. But you still need to pay something because you're hosting that server somewhere. But for the moment, in terms of LLMs and API calls, and if you want to build something serious, there's nothing better than working with OpenAI GPTs and different endpoints for everything actually. So we're trying to work locally just to show how the architecture could be and how we could do the things. But we don't have enough power at home to make those LLMs running at full capacity. So here is more like an example, just to give you some ideas. But I hope that you liked this video and that you know how you can implement it for your own projects. Right, see you next time.